Hello, pre-calcers. Today we have lesson 81, law of cosines. We just learned the law of sines a few lessons ago. Now we're going to learn the law of cosines. Okay, let's do a little bit of a backtrack. Solving triangles. Okay, every single triangle has 6 parts. It has 3 sides and it has 3 angles. Okay, now a triangle can be solved if one side and 2 other parts are known. Right, we did this with the law of sines. Now, if it was a right triangle, we use trig. And if it's not a right triangle, then we can either use law of sines or law of cosines. Now, in the law of sines, we have an angle and a side opposite is known. That's not true of the law of cosines. So let's get into the law of cosines. Okay, there are 3 forms. A squared is b squared plus c squared minus 2bc cosine of A. B squared is a squared plus c squared minus 2ac cosine of B. And c squared is a squared plus b squared minus 2ab cosine of C. Okay, a couple ways that you can remember this. Okay, if I have a squared, then over here I have b squared c squared and I have bc in here. This always corresponds with this. Okay, you should never have something that does not correspond. Okay, now another little thing to remember is Saxon uses little p and big P to relate pairs. That's silly. We're not going to do that. We're going to do it like this. Okay? Now, I think it will be easiest if we get into an example, and I'll explain more things as I go in the example. Okay? So, example 1, we're going to solve the triangle for unknown parts. So here's my triangle. We have 7, this is y, x, 36, m, and 10. Now, we know that we are going to need to use the law of cosines because we don't have a single pair to do for the law of sines. Okay, and we remember that the law of cosines, we have c squared is a squared plus b squared minus 2ab cosine of C. Okay, now the pair we wish we had its side, right, because we have the angle, is x. So I'm going to say that x squared, right, now I'm doing x squared because I know my other sides. So 10 squared plus 7 squared minus 2 times 10 times 7 cosine of, now the corresponding angle is 36. Now, the super fantastic thing is you can do this all as one step in your calculator. X squared is 35.74, which leaves me that x is 5.98. Okay? It's really fantastic that we have that because we are able to make our lives really easy and use a different form from here on out. Okay? Yes, you do need to memorize the law of cosines. Now from here, we can use the law of sines. We can say that 5.98 over the sine of 36 is 10 over the sine of y. And we should know how to solve this. We say 10 sine of 36 is 5.98 sine of y. So the sine of y is 10 sine of 36 divided by 5.98. And y is the inverse sine of all of that, which gives me that y is 79.39 degrees. And I do the same thing for m to get that m is 43.47. Okay. Now, the only other thing that we find is we can actually get a couple different values for y and m. Okay, if we look at our triangle, we see that m should be less than y, and it is. And we could manipulate it in a couple different ways. The important thing is you don't need to know that. Okay? All right, so let's do another example. Example 2, again, we're going to solve for the missing parts of the triangle. Now, again, we know we need to start with the law of cosines because we have, we don't know any of the angles, so we don't have a pair. Okay, so again, we have c squared is a squared plus b squared minus 2ab cosine of c. Now, I want to find the angle c, so I'm going to say 7 squared is 8 squared plus 5 squared minus 2 times 8 times 5 cosine of x. Okay, now if I move everything over, I get 40 is 80 cosine of x, So 0.5 is the cosine of x. Now, this is where it's interesting. The two answers, now it comes in P important, is we know that x is 1/2 in two places, 60 and 300. Okay, but clearly we see from the picture x is not 300, so x is 60. Okay, it is important to notice your picture. Now we use the law of sines. We can say 7 over the sine of 60 is 8 over the sine of y. And from this we find that y can either be 8.177 or it can be 98.23. Again, because sine is positive in two places. Now, the important thing again is we look at our diagram and we see that y is not bigger than 90 degrees. So we go with 81.77. And then we know that 60 plus 81.77 plus z is 180, and we get that z is 38.23. Okay? Let's do another example. Okay, let's say we have this triangle. This is M, 28, 10, 14, B, and K. Again, c squared is a squared plus b squared minus 2ab cosine of c. Okay, I want to look for K. k squared is 10 squared plus 14 squared minus 2 times 10 times 14, cosine of 28. That's a 28. Lovely thing is you can plug this all as one step in your calculator, and you get that k squared is 48.77. So k is 6.98. Okay, now we have the side lengths of all of our sides of our triangle, but we can't find any of the other angles by using the law of cosines. To use the law of sines, we need to find M or B. Okay, now we do have one pair, so we could use the law of sines. It might be easier to use the law of cosines though. So let's do that. So let's look for M. We have the pair here, so we would say 14 squared is 10 squared plus 6.98 squared minus 2 times 10 times 6.98 cosine of M. Okay. Now, we solve this again for M. We get the cosine of M is negative 0.3387. So M is 109.80. Now the calculator knows that if a cosine of an angle is a negative number, the angle is in the second quadrant. Okay, but we know that this is not an ambiguous answer, right? We can find the exact answer using the law of cosines. Okay, and it's easiest to solve for M first because M is obtuse and it helps us know kind of where B will be. And again, we can say 180 minus 109.80 minus 28 gives us B, and it gives us that B is 42.20. Okay, now let's do a practical example. Okay, so let's say we have two cables that are attached to a vertical tower, thus. And the longer cable is 150 feet and is attached to the top. Okay, the angle between the two cables is 15 degrees. And the shorter cable is attached at a point 50 feet lower than the upper cable. Okay, let's call this angle B, and let's call this L for the length of the shorter cable. We want to find the length of the shorter cable. Okay, now we are first going to use the law of sines to find angle B. Okay, we can say that 50 over the sine of 15 is 150 over the sine of B. Okay, we do this so that we can then use the law of sines to solve for L because we don't have an angle pair with L. And this gives us that the 50 sine of B is 150 sine of 15. So the sine of B is 0.7765. B is the inverse sine of that, which gives me 50.94. Now we have a problem. B, we can see here, is not an acute angle, but we've got an acute angle. Now the reason for this is because sine is positive in both the first and the second quadrants. So what we need to do is we need to do 180 minus 50.94 to give us 129.06. That is our actual angle we are going to use. You have to be aware that this is not an acute angle. And we know that sine is positive in both the first and the second quadrants. All students take calculus here and here. we got the angle that was here, but we need this angle, okay? Really got to be aware of that. And then I can find this little angle here. Let's call it A. I know that A is going to be 180 minus 129.06 minus 15, which gives me that that is 35.94. So that I can use the law of sines. L over the sine of 35.94 is 50 over the sine of 15. So L sine of 15 is 50 sine of 35.94. So L, we get 50 sine of 35.94 divided by the sine of 15, which gives me about 113.39 feet. Don't forget units. Okay, very, very important. You will be docked points for not having units. Okay, super important that you remember that. Super important too that you remember here, we got an acute angle, but this is not an acute angle, so we had to do 180 minus this. Okay, in our other triangles, we ended up getting a little lucky and we didn't have to do that, but you need to be aware of if you have an acute angle or an obtuse angle. We can talk more about that in class tomorrow. That is all for today.